in this video, I'm going to talk about how to use the DC Circuit Builder app, which is an online tool, in order to do a virtual lab. So yeah, we're actually going to do sort of a quote lab for this unit here. So first thing is the handout for it, which you're going to be filling out and submitting, is this right here. You can find it in the Google Drive. And most of the action is going to happen, if not in your calculator, on the SimBucket link right here, which will take you to this. If for some reason it doesn't work, then you should Google DC Circuit Builder, and it's the one that is on simbucket.com. All right, now what you have right here in front of you is a simple, super simple circuit. We got a battery here. Right now it's set to be a 9-volt battery. We'll actually change that to 10 volts in a little bit, but as you can see, there's some wires connecting a light bulb, all right, and then the circuit is complete, and therefore the electricity flows, which is animated by these little plus symbols right here. Now, if I want to, say, delete a wire, then I can select the X, and oh, as soon as I delete a wire, you'll notice it shuts off. All right, and now the current no longer flows because the connection is broken. This app also has a function for switches, which is kind of fun, but we're not going to mess around with that during this lab, in fact. Okay, now the circuits that you're going to build are all going to involve things like, well, a light bulb, or just a simple wire connector, or whatever it may happen to be, and you're going to connect it up in a variety of different ways. Depending on what exactly the activity is. So objective number 1 says you're supposed to design a circuit where you have 4 equally bright bulbs where each one uses, it says 10 volts. Well, in order to get the number of volts right and everything, you have to follow these directions in bold up here. It says for the purpose of all this stuff, the resistance of a bulb is 10 ohms. There's also generic resistors. I prefer to use light bulbs for labs for a variety of reasons, but mostly it's you have immediate visual feedback, right? It's either bright or dim, and that tells you how many volts it's using / how much current it's receiving. So we'll be using light bulbs as our resistors. And then the other key statement is this one right here, okay? You've got to set the battery to 10 volts, and for all of the activities you are going to do, you're going to use 4 bulbs. Okay, how do I adjust the battery and stuff? Well, there's 3 tabs over here, as you can see, right? There's this one for drawing. There's this one over here, which is where you actually are allowed to adjust the values of things. So I could adjust, if I wanted to, the resistance of this light bulb. You can see it's set at 10 ohms. That's actually where I want it, and do not change that, all right? You aren't allowed to resolve a question by changing the battery voltage or changing the resistance of the light bulbs, okay? So battery voltage, I want it to be 10 volts, so there we go. I can change the 1s and 10s places separately, but whatever. 10 volts is exactly what I want. All right, and now let's, we'll complete this, but maybe change things up a little bit. Let me add in another, oh, that's right. It wants me to delete it. I'll put in a second light bulb there just for fun, and also so that we can demonstrate something important. There we go. All right, current is now flowing. Now, there's a couple of different ways that you can determine whether or not a bulb is using, it says 10 volts or 5 volts or 2.5 or whatever it may happen to be, right? Other questions specify dim versus bright. So as you can see, these bulbs here are relatively dim, but if we want to know how many volts the bulb uses, that's actually conveniently displayed right on here for us. So the assumption about a bare section of wire like this is that it's for this app anyway, that it's a perfect conductor. It's not actually quite a perfect conductor, and they actually had to build that into the app a little bit because of the possibility of what if somebody builds in a short circuit. What is a short circuit, Mr. Erica? Well, a short circuit, watch, one of these light bulbs is going to turn off when gosh, I don't know what. There we go. This light bulb just turned off. It's not lighting up at all. Okay, well, the reason it's not lighting up is because we have 0 ohms effectively this way, and 10 ohms this way. And so therefore none of the current will want to go through the 10 ohm bulb. All right. So if you get to a question where it's asking about making it so that one of the bulbs doesn't even light up at all, then you're being asked to design a short, basically. Yeah, so whenever it says something is short circuiting in real life, it doesn't mean it is broken. It means there's an easier way for the electricity to go. It's found an effectively 0 ohm path rather than going through the path you want it to go. Okay, now I kind of interrupted myself. How do I know how do I know how many volts a particular circuit element is using? Well, so it says 10 here and 10 there. That means this section of wire is using 0 volts because the difference between 10 and 10 is 0. And anytime you measure volts, you have to measure it between 2 points. So between here and there is a difference of 0 volts. Therefore, no volts are being used by that segment of wire or by this one or by any of the other bare wires. But notice right here, it says 10 and then 5. Well, the difference between 10 and 5 is 5. So that means that light bulb is using 5 volts. And so is this one. Mr. Errico, are light bulbs always going to use 5 volts? They most certainly are not. And unfortunately, this app actually is going to round things a little bit. Turns out you can't just replace. You have to delete and then put in a new thing. There we go. All right, so the values we're getting now are 10, 6.7, 3.3, and 0. Okay, I think you can probably see what they're trying to go for is 3.3333 volts, right? But it only displays 1 decimal place of precision, right? Okay, so but you can basically see whether or not you have done it, right? Have you achieved the conditions that it says, right? Did we use the correct number of volts? And again, all of the ones you are going to do will use 4, count them, 4 bulbs. So I'm only using 3 here. This isn't the answer to any of them. I'm just trying to show you how the app works. Right, now, let me work out a hypothetical example here so that you can so that you can see how this is maybe supposed to look. So the hypothetical example here says we're going to use 3 bulbs, and one's going to use 6.67 volts. Ooh, and the other 2 are supposed to use 3.33 volts. All right, now that's kind of tricky right there. Now, so there's maybe a couple of clues that we could use here to achieving our goal, right? One of them is this. If all of these bulbs have the same resistance, all of them have the same resistance, the number of volts that they're going to use is going to have to depend on the current, right? If they are all 10 ohms, and we need some of them to use more volts than the others, well, then the one that's going to use the most volts has to be getting, let's say, I total. Okay? Because if one of them is getting the total current, that one's going to use more volts than the others, because they all have the same resistance, but if one is getting more current, then it's going to use more volts. All right? So maybe, here's my first idea, right? I'm going to say, there's my series light bulb, right? And then it's got a split, right? Because only one can get I total. That would be the one that's using the most volts here. All right. The other 2, it says use 3.33 volts. Well, if they are getting the same number of volts as each other, odds are pretty good they're going to be in parallel, right? They could also be in series with each other and be using the same number of volts. So just as another hypothetical, right? If I had bulb, right? If they've got the same current going through them and their resistances are identical, which they are in this case, then that would mean that they would have to use the same number of volts because the current and the resistance would both be the same values. All right, now that doesn't help me here, right? These ones would have to use the same number of volts regardless of anything else because they are in parallel, okay? So now I can try this arrangement and see if it works. And I just made this one up on the fly. I really hope it works. All right, so let me build that circuit. Oh, sorry, I built it, or I drew it in maybe a screwball kind of a way, which it would be hard to build in the actual app. So instead, let me maybe draw it like this, because that's more like what I would be able to build. All right, let me pause the screen and try and build that and see what we get. Here's that I have done it. In fact, Mr. Erico, it says 3.3. I'm pretty sure. No, look, see, it's 10 on this side of the light bulb and 3.3 on the other side. Rounding, it only gives me 1 decimal place, frustratingly. But that's 6.7 volts across this one and 3.3 across each of the other two. All right, so it looks like I've done it. Now, you'll notice that all of the various examples ask you to calculate a few things. So, for example, they might say, what's I total? What's R equivalent? Let me see, what order do they ask for that in? R equivalent first. Okay. All right, R equivalent, I total. And then the other one that it says is usually something like I each, or it might say I bright and I dim, because you'll notice that we have a bright one and we have a dim one. It's always going to be the case that the one that receives the total current, which would be this one, is going to be the bright bulb. Whereas the other two, these ones are going to be our dim bulbs because they only receive part of the current. Okay, so bright, dim, total, all that good stuff. All right, well, you guys know how to do the calculations to determine equivalent resistance, so I won't bore you with that process. It's going to be 15 ohms. Since, remember, each and every one of these light bulbs is 10 ohms, right? 10, 10, 10. Okay, so you can calculate how it's 15 ohms. All right, so that means that I total is going to be, well, let's see, V over R equivalent. I don't get a real nice number here, right? 10 over 15, so that would be 2/3 amps. I guess it's not such a bad number, all right? All right, so the bright one, that would be this one, since it's in series with the battery, receives the total current. It won't always be the case that your bright bulb receives the total current, or at least it might not be. It can certainly happen, but in this case, I totals 2/3. That's the current through the battery and also through everything in series with the battery, which would be our bright bulb. Whereas the two dim bulbs, well, I don't necessarily have to do a loop equation here, okay? I can just use ratios or whatever other tools I have at my disposal, but if I've got 10 ohms this way, 10 ohms that way, equal resistances on either branch, that means that the current is going to split evenly, so each of those will get half of the current, which would be 1/3 of an amp each. All right, if you had some other situation where, obviously this would be changing things around a lot, but if there was a second light bulb on this branch here, so that now the resistances are different on those two branches, then you might have to use a loop equation or some other means of calculating it, okay? Hope I've anticipated most of your difficulties with the app lab. If not, please email me and I will try to answer any and all of your questions. All right, guys, I'll see you on the internet.